For Lab 8, Experiment 2, I'll be doing the 2-bit memory cell, but instead of using the D flip-flop like the last experiment, I'll be using the JK flip-flop because 1, I needed to include the reset function, and 2, I wanted to avoid the SR invalid state when both the set and reset inputs are active. For the inputs, I have the clock input, the address selector switch, and the reset switch on switches 0 to 3, respectively, as well as their current LED status above. I have output 0 on LED R8 and output 1 on LED R9. Testing out the first bit, we can see the input is not stored when the clock signal is inactive. When the clock signal is active, we can see the current input is stored on the next clock cycle. When the clock signal is inactive, the current input does not change the output stored in memory. Activating the reset switch resets the input on the next clock cycle. Switching the address to the second bit, we can also see the input is not stored when clock is inactive. When the clock is active, the current input is stored on the next clock cycle. When the clock signal is inactive, the current input does not change the output that is stored in the second bit. Activating the reset switch resets the input on the next clock cycle. We can also save inputs on both bits at the same time by using the address switcher. I'll show that now. Okay. And then we can also use the address switcher to reset our bits one by one. So as you can see, the output 1 was reset. And if we change the address switcher to 0 on the next clock cycle, output 0 gets reset.